Calcium presence in water supplies results from passage over deposits of limestone, dolomite, gypsum and gypsiferous shale. Its concentration may extend from 0 to several hundred milligrams per liter, depending on its source and treatment. Calcium is necessary in plant and animal nutrition since it is an essential constituent of bones, shells and plant structures. Calcium in water as carbonate is one of the primary components of water hardness, which can cause pipe or tube scaling. The HI758 calcium checker HC is extremely simple to use. First, zero the instrument by adding reagent A, deionized water and 0.1 milliliter of sample into the vial. Insert into the HI758 and press the button. Next, remove the vial and add reagent B and shake to dissolve. Reinsert into the checker HC and press the button to read the calcium concentration in ppm on the display. Use for quick and accurate on-the-spot analysis. Single button operation. 0 in measure. Range: 200 to 600 ppm. Resolution: 1 ppm. Accuracy at 25 degrees Celsius, plus or minus 6% of reading. Light source: light emitting diode at 610 nanometers. Light detector: silicon photocell. Environment: 0 to 50 degrees Celsius, 32 to 122 degrees Fahrenheit, max 95% RH non-condensing. Top reviews from the United States. More accurate for me than others make it out to be. To start, it's a Hanna checker, so doesn't get easier. I'm not sure how others like BRS have had such a hard time getting accurate readings with this, as every time I use it and double check off a Red Sea kit I am within 10 ppm ballpark readings, which I can verify off DKH and pH readings to see if those seem reasonable and accurate. They do. For example, I got a 360 reading one time and checked pH and it was down to 7.83 and DKH was down to 7.4, so right in line with what I would expect those to be based off a 360 reading when I'm normally running 430-ish 9.8 and 8.2 respectively. All that said, I still don't trust it 100% yet and always confirm pH and DK to verify, as well as running other testing to make sure it comes within reasonable ranges of what the Hanna says. One place I think is confusing for many and makes for inaccuracy. As you fill with 1 milliliter solution, then fill to 10 milliliters mark with Rhodi. I have a feeling many are putting in 10 milliliters Rhodi on top, being 1 milliliter too much and debuting the sample by 10% more than should be. I'm also using the mark on the vial similar to how one is supposed to use the API kits, where the top of the bubble is at the line and the bubble protrudes just below. This is how this is supposed to be used. The few times I tried measuring with a syringe, I got readings way off what I was expecting and was verified to be wrong with other tests. Maybe the syringes are off, maybe people droppers are off. IDK. But having good eyes and having used and still using API tests for certain things, fresh and salt, I'm getting readings with 10 to 15 ppm of what it should be other testing and what DK and pH readings are.